My name is Paul Wright. I'm a Master Mariner and a Fellow of the Nautical Institute. This lecture is titled SOLAS and the ISM. The lecture aims to explore the contents of the Safety of Life at Sea Convention with a particular focus on Chapter 9, the management of safe operation on ships. This is required to be carried out through the International Safety Management Code. At the conclusion of this lecture, you shall be able to outline the contents of the Safety of Life at Sea Convention, examine the objectives and implementation of SOLAS Chapter 9 and the importance of the ISM Code, distill the responsibilities of the ship's master and the shipping company for the development and implementation of a safety management system, sometimes referred to as SMS. A brief background to SOLAS. SOLAS stands for the Safety of Life at Sea Convention. It was first adopted in 1914 in response to the sinking of the RMS Titanic. Revisions to the SOLAS Convention occurred in 1929, 1948, 1960 and lastly in 1974. The present edition of SOLAS is referred to as SOLAS 1974 as amended. SOLAS 1974 is regularly amended through a system known as tacit agreement. The tacit agreement process ensures that the Convention develops with changing technology. The main objective of the SOLAS Convention, as stated in the International Maritime Organization, is to specify minimum standards for the construction, equipment and operation of ships compatible with their safety. The sinking of the Titanic, the unsinkable ship, gave rise to the development of the Safety of Life at Sea Convention. It is a key maritime convention. The areas covered in the original 1914 convention included construction, life-saving appliances, safety of navigation, wireless telegraphy, and certification. With the exception of wireless telegraphy, which is given over to satellite communications, these systems can already be identified in the present 1974 SOLAS Convention. There are at present 13 chapters in the SOLAS Convention. Each chapter covers a different topic of interest. It is expected that a 14th chapter, concerned with the adoption of an international code for the safety of ships operating in polar waters, known as the Polar Code, will be added in 2017. Flag states are responsible for ensuring that ships under their flag comply with the requirements of SOLAS. A number of certificates are prescribed in the Convention, and these have to be retained on board the ship as proof that the flag state has complied with its responsibilities. This lecture is now going to consider Chapter 9, the management for the safe operation of ships, which requires the compliance of all ships with the International Safety Management, the ISM Code. This is concerned with improving the quality of ship management. The development of the ISM Code was the direct result of the capsize of the roll-on roll-off ferry Herald of Free Enterprise in 1987. A picture of the ship is shown here. The Herald of Free Enterprise was leaving the port of Zeebrugge. Its bow doors were open and that was unknown by the bridge. On departing from the port and entering into the English Channel, water was taken on board onto the car deck. A capsizing moment was created and the ship capsized, fortunately capsizing onto a sandbank. Nonetheless, 193 persons died and questions were asked. This was the biggest loss of passenger life on board a British ship since the sinking of the Titanic, except of course for wartime. An inquiry was established, and it was found that there were serious deficiencies in the management of the ship and of the company. And whilst the open bow door was the initial cause of the incident, it wasn't the only cause. The judge who conducted the inquiry, Lord Justice Sheen, made this statement which is well known. He said that from top to bottom, the body corporate was infected with the disease of sloppiness. The incident was only one of many in the 1980s in which concerns were raised about the human factor and the culture in the shipping industry towards safety. An opportunity was taken, the creation of the International Safety Management Code. This was the response which supported changing attitudes towards safety in the shipping industry. A culture of unthinking compliance with external rules moved towards a culture of thinking self-regulation of safety and the development of a safety culture. That is, a culture in which every individual feels responsible for actions taken to improve safety. The picture you see here is of a recent incident in Southampton Water, where a large 8,000 vehicle carrier, the Hogue Osaka, capsized as it was rounding Bramble Bank. The incident was investigated and there was found to be deficiencies in the management of the ship. The aim of the International Safety Management Code is to ensure that safety at sea, the prevention of human injury or loss of life, and the avoidance of damage to the environment are in fact maintained. To ensure that the objectives can be accomplished, a shipping company must devise safety management objectives. Amongst other matters, they must provide safe practices in ship operation and a safe working environment. The objectives must also assess risks to the ship, to personnel, and to the environment. And finally, they must improve the safety management skills of not only personnel aboard the ship, but also aboard at shore, including, of course, in preparation for emergencies. A safety pyramid diagram is shown here which illustrates the relationship between unsafe acts, near misses, lost time and death. Time and effort spent in reducing unsafe acts will eventually reduce the number of accidental deaths. As seen in this particular pyramid, 30,000 unsafe acts will lead to 3,000 near misses. 3,000 near misses will lead to 300 lost time injuries, and 300 lost time injuries will lead to one death. This gives an idea of why we have to have a system which in fact tries to minimise the amount of unsafe acts, for they will eventually cause deaths of persons on board. The SMS, or the Safety Management System, is a requirement of the ISM code. Every ship is required to have a safety management system on board, and this will include the following: a safety and environmental protection policy, instructions and procedures to ensure the safe operation of the ship and the protection of the environment in compliance with international and state legislation, define levels of authority and lines of communication, particularly between shore and ship-based personnel. In addition, procedures for reporting accidents and also for reporting non-conformities, procedures to prepare for and response to emergency situations, and finally, procedures to undertake internal audits and management reviews. Whilst there have been objections to the establishment of safety management systems, what is actually undertaken is nothing less than best practice, which has been undertaken by many shipping companies throughout the years. It was recognised that there were problems in implementing the ISM code. First of all, the safety management system requires commitment. Commitment from the top. That is from the directors, the managers and the supervisors. You may ask why. Well, the directors, managers and supervisors have got interests which of course are of a financial type. But in addition to that, they are now being forced to ensure that they have an interest in safety of their ships of which they operate. So commitment from the top, is what is necessary. There is also the need for commitment from other employees. Without commitment, effort will be wasted. Each company will differ in detail, but the directors will need to provide the material and financial resources needed to develop and maintain a safety management system. For many years there have been barriers between ship and shore. For a safety management system to be made effective, the barriers have to fall. And this was certainly the case in the Herald of Free Enterprise incident, where ship's masters were informing the shore managers that there were problems regarding the closure of doors and their being informed about that, and shore management ignoring what they were being told. All persons, both sea and shore personnel, have to be encouraged to cooperate in the development and the maintenance of the safety management system. The system is dependent on all working together. In the past, the ship's master was master to none other but God. Today, the ship's master is an employee of a shipping company. He therefore has to, in fact, work within the requirements of the shipping company. The shipping company also has to recognise this, and so there has been established somebody called a DPA. A DPA is known as a designated person ashore. To ensure the safety of the ship, and that links are provided between the company and those on board a ship, a member of management will be given the responsibilities to confirm the effectiveness of the safety management system, to report deficiencies to the highest level in the company, and to organise safety audits. A designated person ashore is not anyone. He is a very special person who will have experience in both safety and pollution control activities. It is a major responsibility of a person who will usually sit on the board so that he can report to the board the concerns and the issues which have been passed to him through the ships and the ship's masters. The ship's master has already been mentioned. He has overall responsibility and authority for what goes on board the ship. He is also required to implement the safety management system on board the ship. He has to observe the safety and environmental policies established by the company, and he has to motivate the crew in the methods required by the safety management system. Importantly, the ship's master has a direct link with shore management for safety matters through the designated person ashore. The master no longer is only authority is under God, but he now can share that authority with the shore managers. This diagram illustrates the important component parts of a safety management system. All elements are part of good operational practice. The diagram, which is adopted from a Seafarer's Guide to ISM, originally published by the North of England P&I Club, has at its centre the safety management system. Crew training and familiarisation, safety management manual, reporting non-conformities, accidents and hazardous occurrences, auditing, key shipboard operations, maintenance of ship and equipment, contingency planning, and a management review are all part of the safety management system. And we will look at some of these now. Training and familiarisation are critical issues for the safety management system. Statutory training courses have to be undertaken by all sea staff, as required by the Standards of Training, Certification and Watchkeeping Convention, known simply as STCW. Safety training courses will include firefighting, the use of life-saving appliances, and for deck officers, the use of electronic systems such as ECDIS. The safety management system will require training drills to be carried out. These are carried out to cover likely emergency situations which could occur to the ship. Crews are required also to be familiar with the ship, and this requires something known as familiarisation. This is an important part of the safety management system and avoids what is sometimes called the pier head jump, where persons will be employed aboard a ship without actually having familiarised themselves with the ship and its equipment before the ship sets sail. So that familiarisation then ensures that duties, including safety management system duties, are always maintained at effective performance levels. It is a requirement of the ISM Code that a company should establish plans for shipboard operations. The subject matter of plans can be developed for many activities, and indeed each ship will have its own individual activities which have to be considered. The International Chamber of Shipping provides guidelines on the application of the IMO International Safety Management Code, and it covers 5 scenarios. These are covered under the headings General, the ship in port, preparing for sea, the ship at sea, and preparing for arrival at port. It is also suggested that the type of operations can be split between special shipboard operations and critical shipboard operations. Special shipboard operations are those where errors may become apparent on or after they have created a hazardous situation, or after an accident has occurred, such as charts not being updated. Critical shipboard operations are those where an error could immediately cause an accident or situation which could threaten people, the environment or the ship, such as navigating in areas of high-density traffic. Summarising this slide, there are 5 scenarios which are provided, and within each of those scenarios we can look at and critically suggest special shipboard operations and critical shipboard operations. A company is required to establish procedures to identify, describe and respond to potential emergency shipboard situations, sometimes known as the what-if situations. The safety management system is required to ensure that any emergency situation can be responded to by the company regardless of time of day or location. Emergency preparedness involves both shipboard and shore-based contingency planning. Within a shore-based contingency plan, the following are likely to be included: the establishment of an emergency response team, and the allocation of duties of team members. For example, we might well have a naval architect, a marine superintendent, or an engineer involved in the emergency response team. Secondly, procedures. Procedures to be followed for different types of accidents. And thirdly, the availability of ship's information, including plans, stability information, and details of safety equipment on board the individual ship. It is also helpful to establish checklists to be used in the different scenarios. In addition to the shore-based contingency planning, a ship must also have a contingency plan. The shipboard contingency plan will consider the different types of emergencies, as indeed it does for the shore-based contingency planning. It too will allocate the duties of those on board and in fact concern itself with the actions to be taken to regain control of a situation. Of importance to be considered are communication methods, both used on board and between ship and shore. And finally, the ship has got also to consider procedures associated with dealing with the media. There are many potential areas which may give rise to an emergency shipboard situation, including fire, main engine failure, collision and grounding, structural failure, man overboard, cargo shifting, heavy weather damage, terrorism and piracy. Is that all? No, perhaps you could think that there are some other areas which could give rise to an emergency on an inboard ship situation. The safety management system also requires reports of non-conformities, accidents and hazardous occurrences to be made. Very simply, under the SMS, the Shipboard Management System, the master has to report the following to the designated person ashore: accidents, hazardous occurrences, non-conformities within the SMS, and suggested modifications to the safety management system. These reports have to be analysed, and after analysis, they may lead to corrective action being taken. It is always incumbent on a company to establish procedures to ensure that the ship and its equipment is maintained as required by the relevant international, national and company regulations and requirements. Procedures are established to ensure that maintenance, repairs and relevant surveys are carried out in a planned, safe and timely manner, ensuring that the seaworthiness of the ship is maintained at all times. As Port State Control inspectors will say, sometimes this is not undertaken as it should be. A company is required to establish and maintain procedures to control all documents and data relevant to the SMS. The documents may be referred to as the Safety Management Manual. They can be kept in a form that the company considers most effective, either electronic, paper, or in sometimes a combination of both. Under SOLAS Chapter 9, a document of compliance, abbreviated to DOC, sometimes simply spoken as DOC, is issued to every company which complies with the ISM code. It is issued by the flag state, and the DOC is valid for 5 years. A ship is provided with a Safety Management Certificate, abbreviated to SMC. This is provided by the flag state again. It follows an initial verification of compliance with the ISM code. It also requires that the company responsible for the operation of the ship has an appropriate DOC. A Safety Management Certificate, like the Document of Compliance, is valid for 5 years. Another activity associated with the safety management system is the audit of the safety management system itself. Section 13 of the ISM Code concerns the issue and validity of the DOC and the SMC. This involves the initial verification, intermediate verification and renewal verification. The work is undertaken by the flag state at the request of the company. In addition to the external verification mentioned above, and recognising the self-regulatory principle of the International Safety Management Code, companies are required to undertake internal processes. The internal processes will help to control the safety management system, and they include the company shipboard SMS audits, SMS reviews and reports which have been given by the DPA, and feedback systems associated with the reporting of non-conformities. Details and guidance of how SMS audits are undertaken, including the competence of the authors, audit scheduling, preparation and planning, conduct of audits and the reporting of audits, are comprehensively covered in the International Chamber of Shipping publication already referred to, that is the Guidelines on Applications of the IMO International Safety Management Code. The reason for the development of the ISM Code was to improve the quality of safety management of ships. The basic idea was to establish best practice across the international shipping fleet. Overall, this has been done. There is criticism as to how much additional bureaucracy some systems have created. Since the full implementation of the ISM in 2002, there have been a significant number of reductions in marine casualties and lives lost at sea. The ISM Code has established self-regulation and a safety culture. Having followed this lecture, you should be able to outline the contents of the Safety of Life at Sea Convention. You will recall there are 13 chapters at present, with a 14th chapter pending. You should be able to examine the objectives and implementation of SOLAS Chapter 9 and the importance of the International Safety Management Code. And you should be able to distill the responsibilities of the ship's master and the shipping company for the development and implementation of a safety management system. A useful paper to read is titled Implementing an Effective Safety Culture and can be downloaded from the website of the International Chamber of Shipping.